Hi, grade 7 students. Welcome back to our science class. Get ready with the following materials. Your interactive science textbook, copybook, workbook, pen or pencil, highlighter, earphone. Are you ready for the lesson? Then follow the textbook page number 528 to 533. Chapter 14, A Trip Through Geologic Time. Lesson number 2, The Relative Age of Rocks. Now let us to check our lesson objectives. Describe how geologists determine the relative age of rocks. Explain how unconformities and folding can alter the order of rock layers. New words in this lesson: relative age, absolute age, law of superposition, extrusion, intrusion, fault, index fossil, unconformity. Review of the lesson. In this lesson, we can going to check what is the relative age of a rock. The relative age of rock is its age in comparison with other rocks. If you know the relative ages of two rock layers, you know which is older and which is younger. Absolute age. The age of rock in years is called its absolute age. Geologists find absolute ages by measuring the amount of certain radioactive elements in the rock. The law of superposition. According to the law of superposition, undisturbed horizontal sedimentary rock layers, the oldest layer is at the bottom. Each higher layer is younger than the layers below it. Look at the diagram. You can see the rocks are arranged in different layers. The higher layers are younger than the below layers. Extrusion and intrusion. Look at the diagram. You can see extrusion, how extrusive rock layers are formed. Lava that hardens on the surface and forms igneous rock called extrusion. Extrusion is always younger than the rocks below it. Look at the bottom of the diagram. You can see a black color. That patch is called the intrusion. How intrusive layers are formed? The magma cools and hardens into a mass of igneous rock called an intrusion. It is always younger than the rock layers around and beneath it. What is index fossils? Fossils of widely distributed organisms that lived during only one short time period. Such fossils are called index fossils. Index fossils are widely used to measure the age of rocks. How old are rock layers? If you found a fossil in a rock, you might start by asking, what is it? Your next question would probably be, how old is it? The first step is to find the age of the rock. Relative age of a rock. Geologists have two ways to express the age of a rock. The relative age of a rock is its age compared to the ages of other rocks. You have probably used the idea of relative age when comparing your age with someone else. For example, if you say that you are older than your brother but younger than your sister, you are describing your relative age. Look at the diagram. The rock are arranged in different layers. The bottom layer is called older and the above layer is called younger. Once we comparing these two layers of rocks, we can say that the bottom layers are older than the above younger layers. Absolute age of a rock. The relative age of a rock does not provide its absolute age. The absolute age of a rock is the number of years that passed since the rock formed. It may be impossible to know a rock's absolute age exactly. So geologists often use both absolute and relative ages. Look at the diagram. The right side of the diagram, it indicates that absolute ages. Once you look at the bottom layers, it's marked as 520 million years ago to 545 million years ago. And the top layers are marked 495 million years ago and 510 million years ago. The same time, the relative age is marked that above layers are called younger, bottom layers are called older layers. So scientists use both these ways to find the age of rocks. Rock layers. Fossils are most often found in layers of sedimentary rock. Geologists use the law of superposition to determine the relative ages of sedimentary rock layers. According to the law of superposition, in undisturbed horizontal sedimentary rock layers, the oldest layer is at the bottom Each higher layer is younger than the layers below it. The deeper you go, the older the rocks are. Once you look at the diagram, the bottom layers are called older than the top layers. Rock layers in the Grand Canyon. Figure shows rock layers in the Grand Canyon. Rock layers like these form a record of Earth's history. Scientists can study this record to understand how Earth and life on Earth have changed. Look at the diagram. You can see rock layers in the Grand Canyon. More than a dozen rock layers make up the walls of the Grand Canyon. You can see 6 layers here. The bottom first layer, it is called Redwood limestone, Subai formation, Hermit shale, Coconino sandstone, Torowip formation, Kebab limestone. These are the 6 layers of Grand Canyon. Clues from igneous rock. There are other clues to the relative ages of rocks besides the position of rock layers. To determine the relative age, geologists also study extrusions and intrusions of igneous rock, faults, and index fossils. Molten material beneath Earth's surface is called magma. Magma that reaches the surface is called lava. Lava that hardens on the surface and forms igneous rock is called extrusion. An extrusion is always younger than the rocks below it. Magma may push into bodies of rock below the surface. The magma cools and hardens into a mass of igneous rock called an intrusion. Look at the diagram. An intrusion is always younger than the rock layers around and beneath it. Look at the first diagram. You can see extrusions. The lava hardens and forms the layers on the Earth's surface. It's called extrusive layers. Look at the bottom diagram. You can see intrusions. How the intrusive layers are formed. Magma cools and hardens inside the Earth. Such layers are called intrusive layers. Intrusion is always younger than rock layers around and beneath it. At the same time, extrusion is always younger than the rocks below it. Faults. More clues come from the study of faults. A fault is a break in Earth's crust. Forces inside Earth cause movement of the rock on opposite sides of a fault. A fault is always younger than the rock it cuts through. To determine the relative age of a fault, geologists find the relative age of the youngest layer cut by the fault. Look at the diagram. You can see a yellow color line and a crack on the top of the diagram. These are called fault lines. Scientists want to find the relative age of a fault. First, they find the relative age of a youngest layer cut by the fault, and they compare with the oldest layer in such a way that they find the relative age of fault. How do fossils show age? To date rock layers, geologists first find the relative age of a layer of rock at one location. Then they can match layers in other locations to that layer. Certain fossils called index fossils help geologists match rock layers. To be useful as an index fossil, a fossil must be widely distributed and represent an organism that existed for a geologically short period of time. Index fossils are useful because they tell the relative ages of rock layers in which they occur. Scientists infer that layers with matching index fossils are the same age. How fossils show age? The scientists first find the relative age of a layer of rock at one location. Look at the diagram. And they compare with the other locations named as location 2, location 3 and location 4. Then they can match layers in other locations to that layer. And they use index fossils. Scientists infer that layers with matching index fossils are the same age. In the location 1, if you find some particular fossils, it is similar to the location 2 and location 3 and location 4. They consider as that one is the index fossil. And they compare that all the locations, and the geologists infer that layers with matching index fossils are the same age. How can rock layers change? The geologic record of sedimentary rock layers is not complete. In fact, most of Earth's geologic record has been lost to erosion. Gaps in the geologic record and folding can change the position in which rock layers appear. Look at the diagram. Rock layers can shift due to faults. Rock layers can be changed due to erosion. Motion along faults can also change how rock layers line up. These changes make it harder for scientists to reconstruct Earth's history. The diagrams shows how order of rock layers may change. Gaps in the geologic record. When rock layers erode away, an older rock surface may be exposed. Then deposition begins again, building new rock layers. The surface where new rock layers meet a much older rock surface beneath them is called an unconformity. An unconformity is a gap in the geologic record. It shows where rock layers have been lost due to erosion. Look at the diagram. You can see unconformity. Older rock layer and new formed layers are meet in an area. It's clearly seen in the picture. Such unconformity is a gap in the geologic record. It shows where rock layers have been lost due to erosion. Unconformities and foldings. Now we can check how unconformities and foldings are formed. Folding bends the rock layer. The surface is eroded. New sediment is deposited, forming rock layers above the older layer in such a way that the unconformity is formed. Folding bends the rock layer. Folding continues further bending the rock layers. Over time, layers may fold completely over. This is called an overtuned fold. Folding. Sometimes forces inside earth fold rock layers so much that the layers are turned over completely. In this case, the youngest rock layers may be on the bottom. Look at the diagram, you can see the foldings. Sometimes the youngest rock layers may be moved to the bottom side. No one place holds a complete geologic record. Geologists compare rock layers in many places to piece together as complete a sequence as possible. Maybe foldings create a gap in the geologic record. We discuss many things in this lesson. This is the time to sum up our lesson. What is relative age of a rock? The relative age of a rock is its age compared to the ages of other rocks. The absolute age of a rock is the number of years that have passed since the rock formed. The law of superposition in undisturbed horizontal sedimentary rock layers, the oldest layer is at the bottom. Each higher layer is younger than the layer below it. Extrusion. Lava that hardens on the surface and forms igneous rocks is called an extrusion. Intrusion. Magma may push into bodies of a rock below the surface. There the magma cools and hardens into a mass of igneous rock called an intrusion. A fault is a break in Earth's crust. Index fossil. A fossil must be widely distributed and represent an organism that existed for a geologically short period of time is called index fossil. An unconformity. An unconformity is a gap in the geologic record. It shows where rock layers have been lost due to erosion. Now let us to check some questions from this lesson. Explain the difference between relative age and absolute age of a rock. Explain the law of superposition. Difference between the extrusion and intrusion. Define the term index fossils. What is unconformity? Now let us to check our follow-up activity in this lesson. Go to the website www.pearsonrealize.com. The relative age of rocks enriched. Download the document and answer it. Post into the website. Do the lesson quiz. I hope that you enjoy and learned many things from my video. Thank you for watching my video. This is the time to sign off our video. Once again, thank you for watching. Good luck.